This is the second video for the Chapter 3 notes. We are starting at the bottom at page 7. The kth percentile, which is denoted P sub k, is a value in a data set that splits the data into two pieces. The lower piece contains k% of the data and the upper contains the rest of the data, or 100 minus k%. So k will be a value between 0 and 100. It could equal 0 and it could equal 100. 50th percentile is the median. Many exams use percentiles to let students know how they scored on an exam in relation to all other students that took the exam. So there's a little formula on here that is to figure out the percentile of a value x. You take the number of values that are less than x and divide by the total number of values and then times it by 100%. You're then also going to round to the nearest whole number. The example below says explain the meaning of the following percentile. The 85th percentile on exam 1 is 92. And so this means that 85% of the class earned less than 92 on the exam. You can also look at the flip of this, and 100% minus that 85% would be 15% earned more than 92 on the exam. The example at the top of the next page says the following data represents the pulse rates and beats per minute of 19 random students at Mount SAC. And those are given in a list, and it says find the percentile of the pulse rate of 71. So in order to do this, we need to count up how many total students there are, which is 19. So that is going to be n is 19. And then we also have to figure out how many of them are below 71. And so there's a total of 6 that are below 71. So 6 are below 71. And I underline those in the list. And so it's going to be 6 divided by 19 times that 100%. And from here we get 31.58 when you put this in on your calculator, percent. But it does say to round, and round to the whole percent. And so the 5 is going to make that 1 become a 2. So this becomes 32%. Or the 32nd percentile. And again, this means that 32% of students have a heart rate pulse that is below 71. Right below, we have quartiles. And quartiles is dividing data into fourths, or 4 equal parts. So the first quartile, or Q1, is the bottom 25%. Then the second quartile is the median, or 50% of the data. And then the third quartile is going to be the top 25% of the data. So in order to do this, we have Q1, we have our median, and we also have Q3. This is splitting things into 4 equal parts. So this is going to contain 25% of the data. The next part will contain 25% of the data. The next part contains 25% of the data. And again, that last part will contain 25% of the data. Quartiles are going to show up throughout different chapters, so there are good words to make sure that you know. So next below says steps for finding quartiles using a TI 8384 graphing calculator. And so what we're going to do is go to stat, our stat button again, go to edit. We need to enter in all of those values into L1. Then select stat again, calc, and 1var stats, and hit enter twice. So from here, you get a bunch of information that we've seen already, but the part that we're going to be looking at this time is going to be Q1 and Q3 and then the median. The example right below says the data represents the weights of each of the 2025 men's U.S. soccer training camp members. Use the data to find and interpret the first, second, and third quartiles for the weights. And so we need to find Q1, Q2, which is the same thing as our median, and also Q3 on our graphing calculator. And then we also need to make sure that we interpret, and interpret just means to discuss and talk about. So the first thing that we need to do is put in all of our numbers into L1 and run one var stats. The first thing to do on our graphing calculator is go to Stat, Edit, type in L1 all of those values, all of the numbers that are given to us, that raw data. Double check your numbers to make sure they're entered in correctly. Next, go to your Stat button again. This time scroll right to Calc, go to one var stats, select Enter, and from here you'll notice that you get your 5-number summary. So your min is the 135, Q1 is 155, median is 170.5, Q3 is 180, and your max value is 215. From the graphing calculator, we got Q1 is equal to 155, Q2, or the median, is 170.5, and Q3 is 180 pounds. So from this, we need to discuss what these mean. So 155 pounds, we're going to say about 25% of weights are below 155 pounds. And again, this is all for that 2025 men's U.S. soccer training camp members. So about 25% of their weights are below 155 pounds. Q2, or our median, is 170.5. And so this is going to be about 50% of weights are below 170.5 pounds. And then Q3 is going to be our cutoff for 75%. So this is going to be about 75% of weights are below 180 pounds. And again, another way that you can always look at this is above. So for Q3, we could have said about 25% of weights are above 180 pounds. And likewise, we could have done the same thing for Q1 and Q2. Right below this, we have what's called a 5-number summary, which is really important in calculating and graphing different things in future chapters along with this chapter. So it says, of a data set consists of the smallest data value, Q1, the median, Q3, and the largest data value. So there's 5 things that you're going to have. It's going to be the min, Q1, the median, Q3, and then our max value. So that would make up our 5-number summary. The example right below says the data represents the weights of each of the 2025 men's U.S. soccer training camp members. Use the data and compute the 5-number summary. And so from this, we need to put the numbers into L1, but they should already be in L1. From the example up above, we do know that Q1 is 155, the median is 170.5, and Q3 is 180. The only thing missing is our min, which is 135. That's the smallest weight that we have, and 215. These are also given to us on our calculator, or you can just look at the numbers to see the min and the max. So your 5-number summary, the way that you can write this is just with commas in between these values and in order. So 135, 155, 170.5, 180, and then 215. The next thing that we have is called a box plot, and this is a graph created using the 5-number summary. It's also called a box whisker plot. There's an example of one right below. And then we have what's called interquartile range. Interquartile range is denoted IQR, and this is the range of the middle 50% of our observations in our data set. So this is going to be found, definitely a formula that we need to know, is Q3 minus Q1. Next, we have outliers, and an outlier is an observation point that is distant from all other observations. So this can occur because of an error or because it's just an extreme value. Down below, we have what's called our box plot. And with our box plot, you can see the min value, Q1, the median, or Q2, Q3, and the max. These are the 5-number summaries, and this is making up your box plot. The other thing to note is that we do also have our interquartile range, or IQR. That's that middle 50%. In addition, you can see that there's 25% in each of these little parts. So to check for outliers, using our quartiles, we need to find Q1 and Q3, and we've done this already above, and this is using one var stats on your graphing calculator. Then we're going to find the IQR, which is Q3 minus Q1. Determine the fences, and so this is our formula that we need for fences. The lower fence is Q1 minus 1.5 times the IQR, and our upper fence is Q3 plus 1.5 times the IQR. If a data value is less than the lower fence or greater than the upper fence, then it's considered an outlier. So we have an example right below that says Anne collects data from the past 12 days on the number of phone calls she receives at work. The number of phone calls are listed, and it says determine if any outliers exist. So the first thing that we need to do is take all of our data and input this into L1 and run one var stats. So input data into L1, and we need to run one var stats. The first thing to do on our calculator is go to Stat, Edit, and in L1 type in all of those values that we have, the raw data. Double check your numbers to make sure they're entered incorrectly. Then go to Stat, scroll right to Calc, go to one var stats, select Enter. And when you do, you get your 5-number summary with the min of 10, Q1 11, median of 12.5, Q3 of 14.5, and your max value of 22. From the graphing calculator, we got Q1 is equal to 11, and Q3 is equal to 14.5. So in order to figure out if we have any outliers, we need to calculate our IQR, which is Q3 minus Q1, or 14.5 minus 11, which works out to be 3.5. And then we need to calculate our lower fence and our upper fence. I'm going to abbreviate LF for lower fence, and this formula that's up above is going to be Q1 minus 1.5 times the IQR. And so Q1 is 11, and our IQR we just calculated is 3.5. Working this out on our calculator, we get 5.75. Next, we have our upper fence, which is going to be Q3 plus 1.5 times our IQR. Q3 we found was 14.5 plus 1.5 times 3.5, our IQR. Working this out, we get 19.75. So these values are our fences. So now you need to look at your data, and is anything smaller than your lower fence? Anything smaller than 5.75? And no, there's nothing smaller. However, our upper fence is anything larger than 19.75. And yes, we have one data value up here, 22, that is larger than 19.75. So we're going to say since 22 is larger than our upper fence, which was 19.75, then 22 is an outlier. So this is an extreme value that we have. At the top of the next page are steps for drawing a box plot. Determine the lower and upper fences is first, which is what we just did. 2 says draw a number line long enough to include the minimum and maximum values. Those might be the fences. Draw vertical lines at Q1, median, Q3, and create a box with these variable lines. Number 3 says label lower and upper fences, and draw horizontal lines from Q1 to the smallest data value, that min value, and Q3 to the largest data value. These lines are called the whiskers. So it says from the previous example about the U.S. men's soccer training camp, create a box plot of the data. So now we're going to create a box plot. I'm going to write down, we already had the 5-number summary. And so we had 135, 155, 170.5, 180, and 215. So first thing we need to do is figure out if we have any outliers. So our IQR, we need to take Q1 and Q3, which we already have, and we're going to do Q3 minus Q1. So we have 180 minus 155, which is going to work out to being 25. So calculating our lower fence, this is going to be Q1, which is 155, minus 1.5 times your IQR, which is 25. Working this out, we get 117.5. Our upper fence is going to be Q3 plus 1.5 times our IQR. And working this one out, we get 217.5. So now you have to check and see if anything's smaller. Are there any weights less than 117.5? And no, we knew that our min value was 135. And then is anything larger than 217.5? And no, the highest weight that we had was 215. So this means that there are no outliers. And so now what we're going to do is we're going to graph this. And so in order to do this, we need to draw a number line that is long enough to include our smallest and largest values, which are actually our fences. So our lower fence is 117 and our upper fence is 217.5. And so I'm just going to start at 110 and I'll count by 10. So 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, and then 210, and then 220. Make sure to label your axes. So this is weights, and it's labeled in pounds. And so I'm going to put my 5-number summary on. Those are the 5 numbers that we had calculated earlier. And so we have 130.5. And do the best you can. This is by hand. I'm going to make these little lines that I'm putting down for the 5-number summary hover above the axes that we have. Q1 is 155. The median is 170.5. Then we have 180 for Q3, and then 215 for our max value. So you should have 5 lines on there. The middle 3 are going to make our boxes. And then from our box on the side, we draw a horizontal line out to our min and a horizontal out to our max. The only thing I still need to add on are going to be my fences, which my lower fence is at 117.5. And these are drawn by brackets. So this would be your lower fence. And our upper fence is 217.5. And again, that's our upper fence. So a box plot can often be used to identify skewedness. We talked about skewedness earlier. This is going to be skewed left, skewed right, or symmetric, or bell-shaped. And so skewed is if a distribution of data is not symmetric and extends more on one side than the other. So correlation between box plots and histograms. And so you can see in here when something is skewed down to the right, we have a longer whisker on the right. If it is more spread out data, like the second one, we have a more wider box here versus the first graph, which is a little bit more condensed. It's more normal. You'll notice that that box is a lot smaller. You also might notice that there's some dots out here, or stars, and these are going to represent outliers. We'll get to that momentarily. So the next example that we have says we would like to compare two distributions of using box plots. A potato farmer in Idaho tests two different types of fertilizers on his potato crops. The table shows the yields in kilograms of potatoes from fertilizer A and fertilizer B. Investigate the effects of the two fertilizers on potato growth. So we have two things here that we need to look at. One's going to be fertilizer A, and the other one's going to be fertilizer B. So we actually have to run our numbers twice. So first thing that we need in order to do our box plots, which is what it wants down here in part A, is I need to get the 5-number summary for both. So you have to do one at a time on these. So the first thing that we're going to do is for fertilizer A is we're going to put in all of our numbers into L1. For fertilizer A on our calculator, we're going to go to Stat, Edit, and in L1 we need to type all of only the fertilizer A values that we have. Double check those numbers to make sure they're done correctly. Then select your Stat button again. Scroll right to Calc, go to 1 var Stats, and select Enter. From here, you'll notice that you get your 5-number summary. 16 as our min, Q1 is 18, median's 19.5, Q3 is 22, and our max is 27. So from the calculator, we get a 5-number summary for fertilizer A of 16, 18, 19.5, 22, and 27. From here, we can calculate our IQR. So our IQR is going to be Q3 minus Q1, which works out to be 4. And then we can calculate our lower fence, which is going to be 18 minus 1.5 times 4, which works out to being 12. And our upper fence, which is going to be Q3 plus 1.5 times 4. This works out to being 28. So looking at your data for just fertilizer A, no values are smaller than 12 and no values are larger than 28. So this means we have no outliers. We need to do the same exact thing, but this time we need to input in all the data for fertilizer B into L1. For fertilizer B, we are going to go to Stat, Edit, and in L1 we need to make sure to type all of the fertilizer B raw data, so only the fertilizer B. Double check those numbers. Then select the Stat button again, scroll right to Calc, go to 1 var Stats, and select Enter. From here, you'll see your 5-number summary. The min value is 18, Q1 is 20, median is 22.5, Q3 is 27, and your max value is 29. From the calculator, we get a 5-number summary for fertilizer B of 18, 20, 22.5, 27, and 29. From here, we can calculate our IQR, which is going to be 27 minus 20, or 7. And then we need to calculate our lower fences and our upper fence. So lower fence is going to be Q1 minus 1.5 times our IQR, which was 7. Working this out on our calculator, we get 9.5. For our upper fence, we have 27, or Q3, plus 1.5 times our IQR. And working this out, we get 37.5. So no values for fertilizer B are smaller than our lower fence or greater than our upper fence. So again, this means that we have no outliers for fertilizer B. So what we have next says to draw a side-by-side box plot for each fertilizer. So in order to do this, we need to have a number line. And we need to look at, since we're graphing a side-by-side, this means we're graphing both of this sets of data I need to look at both of these values and what the smallest value that I have is and what the largest value is that I have. So the smallest value that we have would have been the 9.5 here for our fence, and the largest value that we have would be that 37.5. So using this, I'm going to zoom out a little bit here so we can see the numbers as we're graphing. I'm going to go ahead and start at 5, and I'm just going to count by 5s out to 40. So 5, 10, 15, 20, 25, 30, 35, and then 40. You need to make sure you label your axes, and so what we're talking about here is yield of potatoes. So for fertilizer A, our 5-number summary is at 16, 18, 19.5, 22, and then 27. Remember, the 3 lines in the middle make our box, and then extending out horizontally to our min and our max values. The last thing I need to add here is going to be my fences, which again are those brackets at 12 and at 28. Now, since I'm graphing 2 graphs here, I have fertilizer A and fertilizer B. I need to label these so we know which one it is that we're talking about. And this is fertilizer A. So next we need to graph fertilizer B. This box plot is going to hover above fertilizer A, not touching it, just kind of right above it. And so fertilizer B, our min value is 18. And then we have 20, 22.5, 27, and 29. So having those lines on, the middle 3 make our box. And then this extends horizontally for the min and the max. And the last thing that we need to add on here is going to be our fences for our lower fence and our upper fence, which is at 9.5 and at 37.5. Likewise, we need to label this. So this is fertilizer B. So make sure that you have them labeled so that way you know which box plot represent which set of data. So right below this, there's a few questions. The first one says, does there appear to be a difference in the yields of potatoes between the 2 fertilizers? And yes, those box plots look different. You can look and see that they are, it looks like fertilizer B is more dispersed. And the reason why is because that one has a larger box, so it looks more spread out. And it also looks like fertilizer A is skewed to the right. We would say this because the whisker on the right side of that box is longer than the whisker on the left. Part C said, does one kind of fertilizer have a more consistent yield? And this would be one that's not so spread out. So being consistent means a smaller IQR. And we'll say yes, fertilizer A. And we'll say has a smaller IQR, or that box in the middle. The example at the top of the next page says, using the previous example on the bottom of page 9, which says Anne collects data from the past 12 days on the number of phone calls that she receives from work. The number of phone calls are, and they are given. And remember, in this data set, 22 was an outlier. So it says create a box plot for this data. So this time we're going to be creating a box plot, and we have an outlier. And this is also sometimes called a modified box plot. But from page 9, we had our data in our 5-number summary. is 10, 11, 12.5, 14.5, and 22. So now the issue is that 22 is actually an outlier. So I'm going to give it a star and I'm going to say outlier. And so it has a special spot on that graph. And that means that it's no longer our max value because now it's considered an outlier. So because of this, we need a new max value. So the question is, what is the next largest value in the data? And so the next largest value that we have in the data is 17. And so this is going to be our new max. So 17 here is the next largest number that we have. And so I'm going to go ahead and replace that and put a 17 up here. And this is our new max. And so from here, from before, we also calculated our lower fence and our upper fence on page 9. Lower fence was 5.75, upper fence is 19.75. So our new 5-number summary is now going to be 10, 11, 12.5, 14.5, and now 17, because remember 22 is now an outlier. So in order to graph this, I'm going to draw a number line. The smallest value that we have is that 5.75. The largest is that outlier at 22. So I'm going to start at 5 and count by 5s. So 5, 10, 15, 20, 25. And what is it that we're talking about with this problem? This is number of phone calls per day. And so from this, using our new 5-number summary, we have a 10, 11, 12.5, 14.5, and 17. Those middle 3 lines are going to become our box. And then again, extending out to our min and max values. And then putting on our fences at 5.75 and 19.75. The next thing that we need to add is our outlier. And our outlier is at 22. And we're going to represent 22, that outlier, with a star. So this is our outlier. And it's 22. I'll put 22 in parentheses so remember this. So double check to make sure that you have your box plot, your fences, your outlier, and your axes labeled. So this is the end of the chapter 3 notes. From here, you want to make sure that you upload your notes as a single PDF file on Canvas.